Good afternoon, one and all. Esteemed Munish sir, Jen sir, Munish sir, Nagma sir, Sama sir, and my loving brothers and sisters, and my dear friends. I am honored to be here to share my insights on the topic elemental particles and their classification. From 90s, it is believed that atom is the fundamental particle which can be broken down. But after the experiment of Rutherford, it is concluded that atom consists of a centrally heavy nucleus and the electrons are revolving around it. Then proton and neutron are discovered, and we get a basic idea in our mind that of atomic structure. Then after that, scientists thought about, is there any fundamental particle that proton and neutron will consist of? This leads to a new branch of physics that is called particle physics. Today I am going to show you that in this area how many research work has been done. In my context, there are in my context there are introductions, particle physics and standard model, fundamental laws and forces in nature, and their classification according to the speed, interaction, and then comes to conservation law, Quark model, color hypothesis, and final conclusion and references. Introduction. Particle physics is a branch of physics that deals with the fundamental particles, interaction, constituents, and many more things. This is known as high energy physics because the most of the elemental particles that we see are generally not found in normal circumstances. They are generally produced and detected using high energy particle detectors and colliders. Now comes to elementary particles. Elementary particles are the fundamental particles that are the building blocks of matter in universe, and these are called elementary particles because they are structureless. They have no structure, and they are not made up of subparticles, and that is there no constituents, and they have no extension in space. That is, they are complex masses. The particles, elementary particles are leptons, quarks, and intermediate particles. Are the true elementary particles because it is elementary particles. Then comes to standard model. Here I have shown a picture of a standard model. This is a theoretical framework drawn by physicists to describe all these elementary particles in a single gap. It includes electrons. There are 3 generations of electrons, 6 electrons, and the antiparticles. And quarks, 6 quarks, 6 level quark, and these are the intermediate particles or bosons. Next comes to fundamental forces in nature. Everything that we see in our nature, all the forces, all the interactions, all these things are broadly classified into 4 forces. These are the gravitational force, the electromagnetic force, the weak nuclear force, and the strong nuclear force. But I have included another force which is known as residual interaction. Let's see how this why I have included this. We know hadrons that we discuss later on, but we just know that hadrons are the elemental particles, fundamental particles that constitutes quarks, and the force between the 2 quarks is governed by the strong interaction, and the force carrier that governs the force is gluons. But after the formation of the hadrons from quarks, the interaction between the 2 hadrons is governed by generally the residual strong interaction, and this residual strong interaction is nothing but a subgroup or subpart of strong interactions. And these are the particles affected, which affect the forces, and these are the rings and the relative strengths with their speed and the role in the universe. Now comes to unification. We have all the forces, all 4 forces. That and we can here is an interesting thing that we can add all the forces to a single theory, that is theory of everything. Let's see how it is. We have the magnetism and electricity separately, and we can add or combine these 2 theory to a single theory, electromagnetism. This is done by Faraday and Henry in 1830s. Then if we add electromagnetism with nuclear forces, we can get electroweak theory. This is done by Abdussalam, Lee and Stephen in 1860s. Then if we add electronic theory with strong interaction, what you get? We get grand unified theory. This is shown by Georgi in 1930s actually. And then if we finally add gravity, grand unified theory with gravity, we can finally get universal interaction or theory of everything. If we get the theory of everything, this is not actually done, but because the gravity is not here today is not combined because it is a time dependent force, so we can add this. If you add, you can get the universal interaction. When it comes to classification, classification of particles according to their spin and interaction. According to on the basis of spin, we can classify elementary particles into two groups, two families, that is boson and fermions. Boson are the particles which have integral spin and they obey Bose-Einstein statistics. And another family is the fermions. Fermions are the half-integral particles that includes interval that obeys Fermi-Dirac statistics. Then for boson family is of two types: is massless boson and mesons. Massless boson are the intermediate particles. It includes photon, graviton, and etc. Then meson includes ions and metals that we will discuss later on. Then comes with second family, fermions. Fermions are two types. Electrons are baryons. Electrons are the two elemental particles I have discussed. Then baryons. Comes to electron family. Electron family it includes electron, muon, and tau, and their respective neutrino and their antiparticles. This includes 12 members. But then comes to baryons. Baryons is classified into two categories, that is nucleon and hyperons. Nucleons are the not strange particles. This includes proton and neutrons. Then hyperons. Hyperons includes four members: lambda, sigma, cascade, omega. That we see later on. Then comes to classification on their interaction. On the basis of interaction. On the basis of interaction, elementary particles we can classify them broadly into two families, that is lepton and hadrons. Leptons are the family which do not take part in strong interactions. Hadrons are the family which takes part in strong interaction. Leptons are classified into according to their generation. By generation, they are detected step by step after the development of physics. We can get this family energy in Kähler electron volt, this family energy in mega electron volt, and this family energy is tera electron volt, which we can get after the development of our detectors. These are electron neutrino, mu neutrino, tau neutrino, tau and tau neutrino in their generations. Then comes to meson. Hadrons. Hadrons are the family I have already told that it obeys the strong interaction, takes part in strong interaction. It has two members, meson and
diagram for copied from formulas.
I have typed this graph. Yes, sir. I have drawn the latter side.
All of this electron, netta, last neuron.
Sir, some जेतिक सर रिकॉर्ड की वर्तमान से कुछ पॉपुलर
So भूल के लिख दिया
थोड़े से
electron तब ये कि netta कौन?
मीटर सर
तो कौन है? तब पूरा स्लाइड neuron input हो गया ये हमारी ONS neuron proton neuron
सर टाइपिंग से न्यूट्रॉन
कमेंट कर देना
सर मुंह कर सर टाइपिंग
में डेल्टा पार्टिकल पड़ेगा रो में
सेटा अच्छी सेटा मैं जितनी सर वो सेटिंग इंक्लूड करते हैं और इस और स्लाइड अच्छी सर तो अच्छी स्लाइड देखो सर कोई
ना इसने कॉपी को किसी करेक्शन करती
their baryons, meson are the neurons which are the internal structure quark and antiquark. It is structured quark and antiquark baryons includes three quarks. The meson family is of two types: pseudoscalar meson and vector meson. Pseudoscalar meson includes pion, cation, antiquark, theta. Then vector meson, rho and chiral resonance and antiquark resonance and omega. Then comes to baryon family. Baryon family includes baryons and baryon resonances. Baryons are the particles of baryons. it includes nuclear lambda sigma cascade. Then baryons. Baryons are the particles. They are the excited baryon particles, which are the low.
You are writing both omega in meson and baryon.
Sir,
No, delta omega, cascade omega. Omega inside baryon, omega inside meson. Actually, it is capital omega and small omega. Okay.
sir, baryon regions particles are the particles of baryons, which is excited on the lower lifetime as compared to baryons. They are the high energy. It includes delta, sigma regions, cascade regions, and omega. Let's see. Leptons. As you have already told, leptons are the elementary particles with half impulse speed and do not take part in strong interactions. It is classified according to generation. First, second, and third. First generation have the energy in kilo, mega, and derivative. These are the they are respectively neutron and the antiparticles. These are the symbols and charge antibody with charge with mass. Then is pseudoscalar meson. Pseudoscalar meson is a meson that total spin is 0 with odd parity. It is made up of two quarks, that is one quark and antiquark. It includes 8 members. The ion family, antiquark family, is ion family, and another one beta prime is also included. This after that is one nonate, but I have already have just added 8 members, so I have nonate. These are the quark contents of its members. If we draw the horizontal lines along this graph, we can get the spin of their respective elements, such as tan 0 plus and 0 with spin 1, 0 and spin minus 1. If you draw slide lines along this, if you draw these slide lines, green lines, we can get respective charges. There are 3 oblique lines. We can get this charge negative, 0 and Q positive. This is vector meson, which is spin parity 1 minus, that is total spin is 1, and with odd parity it is includes quark and antiquark, and these are again 8 members with can resonances, antiquark resonances, and rho particles with omega at the center. The baryon octet. Then comes to these are the baryons. This includes the baryon family are the heavy subatomic particles which takes part in strong action. But the previous 2 slides, the elements do not take part in strong interaction. These are the particles which take part in strong interaction. They are of 3 quarks. They are made up of 3 quarks, and they have the total spin with half, and they are even parity. It includes nucleon and hyperon. Nucleons are this family with not strength particles, or strength 0, and these all 2 particles are strength particles, which include strength quarks as shown. This strength is -1 and this is strength -2. These are the cascade family. This is sigma family, and this nucleon family. This is centroid lambda 0. Then comes to baryon resonances. These are again the baryon resonance family is I have already told that baryon resonances are the particles with higher energy and lower lifetimes. These are the baryons with total spin 3/2 with even parity. It includes 12 members. That 10 members. 10 members. The upper 4 members are the delta family. Belongs to delta family. Is middle layer belongs to sigma resonance family. These are cascade resonance, and this omega. If we draw this horizontal lines, we can get the spin of 0, -1, -2, -3. And if we draw the slide lines, we can get the respective charges. This graph is drawn considering the high component of isospin with hypercharge. Then comes to conservation law. All the nuclear reaction we see, it is possible or not. If I will check, we can check by the conservation law. So conservation law as a particular is a fundamental principle that describes the behavior of physical system. How it is going to be, or this conservation law is crucial and for understanding and predicting the outgoing products. The conservation law is of 2 types, that is exact and approximate. Exact conservation law are the law which is conserved in all the interactions, that is gravitation, all the 4 forces.
Why do you give this name? Exact and approximate conservation, where you get those value? Who will it? Who will it? Short term? वही को वही बढ़िया वही बनना सीके लेती हो वो स्लाइड है सेटअप नहीं अच्छा लगा
नहीं है सर वही
को वही
देखिए सर conventional law is a two types exact approximate. Exact conventional law at the law which is conserve all the interactions, all the four interactions, and the approximate interaction is the interaction which may or may not be conserved in all the interactions. Conventional all the exact in conventional law are the charge, electron number, baryon numbers, and the approximate conventional law are the associated hard common associations, parity, etc. Here then we have shown here a tablet form. These are the charges, energy, all the entity, strong interaction, free interaction. But I have not shown the gravitational force. These are the small nuclear masses, so that reaction is not there. Then these are the interactions and electromagnetic strong interaction. They are shown. Then comes to Quark model. Quark model. Quark model. The Quark model is a theoretical framework that is drawn by the physicists to describe about the building blocks of matter, that is quark. This is developed by Murray Gell-Mann and George in 1960s. This model was successful for explaining the structure of hadrons, such as meson and baryons. According to this model, meson consists of quarks, two quarks, one quark and antiquark, and while the baryons are consists of three quarks. Here is the structure of meson and the baryon. There are two quarks, one quark and antiquark. These are the three quarks. Then comes to color hypothesis. Why this hypothesis? This is only we understand because we know quarks have the spin 1/2. These are fermions. So fermions, according to fermions obey the Pauli exclusion principle. According to Pauli exclusion principle, not two fermions, two or more fermions can stay in single quantum state. So there is another quantum number is introduced to solve this theory. So it is called color hypothesis. According to this hypothesis, a quark exists in three colors, that is red, blue, and green. And antiquark is exists in three colors, that is anti-red, anti-blue, anti-green. Further, we know that all the naturally occurring particles are colorless. So the colorless means either each color is present in the same amount or net color amount is zero. Then in case of baryon, which consists of three, but all the quarks are present in the same amount, so it can produce a colorless combination. And then whereas the meson are will consist of one quark and the net amount of each color is zero. There's some combination, colorless combination. This is some combination red, blue, green, colorless combination. Colorless combination is not transparent or not white but transparent. These are the colors, and this is two figures. This is the proton figure, neutron figure, Quark model figure. So two upward and two downward with different colors, red, blue, and green. This is the structure of neutrons with one upward and two downward in different colors. Finally, let's come to conclusion part. In conclusion part, first we have seen the standard model, how it is successfully tells about the fundamental particles and forces. Secondly, the elemental particles describes in terms of spin and interaction. Thirdly, we have checked the conventional law whether the interaction is going to proceed or not. Finally, we see how the particle and antiparticle are explained in terms of the quark content and spin and parity. These are my references which I have seen in it.